It's a pleasure to see you everyone here in the morning, in the early morning. I hope your after party goes well. I'm here today to speak about Flow. I think all of you know who I am. I'm the owner and the leader of Wookie Labs, small company which is developing just JavaScript services. And it's a miracle that I'm saying that, but we are hiring. So if JavaScript is your religion, not just the way of earning money, let's get in touch. I'm also the coach in JavaScript Ninja, courses where I try people to learn something JavaScript related. And of course, I'm in Kotlin, I consider. We are driving our community to be a better thing. So, today we will speak about Flow. Flow is another type system introduced by Facebook. It is written in OCaml. OCaml is the language that no one knows, I assume. Me too. It is a client-server thing, so when you launch Flow server, it launches in your folder, scans all your files, and after that, everything you are using, IDE, command line tools, is communicating to this server. It is based on a OCaml type system, which is based on a pretty strong mathematical backbone, on types, all that complex functional programming stuff people usually ignore, normal developers, I mean. And Flow was originally developed to fit Facebook purposes, and it is very heavily dog-fooded by Facebook. That means that almost each JavaScript project in Facebook internally uses Flow. That's why Flow is more bind to fit Facebook purposes. We will see that later. And why we will always feel a small smell of React, because the Flow was originally developed to solve some problems with React codebase. Frankly speaking, Flow is underdog. When you speak about typing, you usually say, yet another TypeScript, huh? Why I should pick Flow over TypeScript? Okay, who loves TypeScript? Oh, you will hate me in 20 minutes. I will break your life, and even worse, I will break your life into untyped pieces. It's always a problem for me to create slides. I always wait till final deadline, so yesterday, after party, I left and went to do slides waiting for inspiration. It was 3 a.m. Inspiration didn't came yet. But instead, the spirit of Linus Torvalds appeared. Was I drunk? Probably. And he said, talk is cheap, show them the code. So this is the last slide of my presentation, and we are jumping right in the code editor. So, first of all, a bit dull part. To make sure everyone is familiar with typings in JavaScript, TypeScript users, you will sleep for next 5 minutes. First of all, how we set up the project. I have an empty folder. What I'm doing is writing in command line Flow init. Oh, thank you, PowerPoint. I love Microsoft products. 1 second, it will be back, thank you. And duplicate. Oh, here we go. Let me check that you will see. Okay. Well, pretty weird scroll bars, but whatever. What I've done the command Flow init. We just created an empty Flow config file into the folder with no configuration. We will not touch this in today's demo. What we will do is, without this file, the Flow will never work. So let's write some JavaScript. First of all, how the types work. You are declaring thing. You put this and say, OK, this will be the number. OK, I'm assigning the number. That will be fine. I'm assigning the thing. No error. Why? Because if you want the Flow to check your file, you should add Flow header. This is required because it allows you add Flow to your existing codebase step by step, file by file. So, you see, OK, now it's an error. Yes, if it says this type is incompatible with number. Okay, pretty dull. We have a special keyword named type, which allows us to create aliases, so we will not repeat things. For example, Redux action thing is the object which have type named string. Yeah? Okay, so const action type Redux action of part that will give us an error. Why? Because property, not property type, not found. So I will add here some type. Oh, that will work. Whatever. Another thing we should know for today's demo is the union of types. So assume we have someone who is using React probably is using Flux standard actions, which signature is type string, payload any. We are telling, okay, here could be anything, and probably payload may be missing, so I'm putting here the sign. Error, also probably type of error. Okay, but it's pretty bad. Why? Because Flux standard action is also a Redux action, right? So instead of this thing, we can say this is Redux action and this. So pretty obvious, right? Type FSA action will have type string, payload, and error. So if I declare something with type FSA action, it will have type and payload. Yes, if I remove, it will be an error because type is required. If I miss payload or error, it will be no error because they are marked as optional, right? Also, I can put some bullshit here. Let's make it correct one. And there will be no error. At least I suppose so. This type is incompatible with number, where I did specify the number. Oh, my bad. So, no error. Why? Because by default, object type in flow type is open. That means that when I'm declaring Redux action, I mean here will be the type string and any other possible things. That's okay. But let's assume I want a strict one. I want this have only these fields. Here we have additional syntax. It starts looking pretty weird, right? And now everything is an error. Why? Because this one, let's do some maths. This one declares, here we must have only payload or error, and that should be a Redux action, right? This one should satisfy both. But how could it satisfy this one, since it has type property? Understand? We are declaring the object with type property, and when we are using AND sign, it's not just merging them together. It's just check it should satisfy this and this. So in order to get this thing to work, I will be forced to do that. Sad but true. And now I will have an error here. Why? Because of this field. And it's gone, and it's awesome. Okay. Sometimes we are doing quite other thing. We are doing, let's bind, like I said, let's bound to Redux theme. So we are writing reducer, which will have some state of state type accepting as parameter. I'm just getting you familiar with flow syntax, so we could proceed. Let's assume I'm too lazy to write state type. So I will say this is any. And action, which is action type. And return type of this function is state type. So here, we need to declare action type. And what would we like to say? Let's assume we have, for example, open pop-up action type, which is type, for example, action open pop-up. Yes, now I'm saying, no, this is just type string, this is exactly this value. And for example, header string, and I have type close pop-up action type, which is pretty simple and is just type action close pop-up. Okay, I will put them to exact mode. And this is how I declare action type. This is open pop-up action type or close pop-up action type. Right now, here, I will get a nice autocomplete. Here you can see, unfortunately, in Visual Studio Code for the moment, there is no nice way to disable TypeScript-based autocompletion. So I'm seeing actually both. But we can see here there is nothing typed. Here is type. This means that it was inferred from flow declaration. So I can write a default switch action type. Okay, here we come. Of course, that will be constants. I'm just too lazy to do that. Action pop-up, and okay, console log header. Action header, that will work. And break, and of course, people say that there should be a case here. And another one, case action close pop-up. Let's say I'm doing an error intentionally. Yep. And, whatever. Default, I will return state. I will also should put returns here, or flow will complain that, okay, you're declaring that you're returning state type, but you're returning nothing. Of course, in that case, I do not break. But here we can see, flow understands that in this branch, this is close pop-up action type, not the open. The flow is able to infer type based on your code flow. So since I've checked the type, and flow understands that based on this check, this could be only this type, it makes correct assumptions. This is extremely powerful way in which we will see it differs from TypeScript. TypeScript is about declaring types. Flow is greatly about inferring types. Of course, it does not mean TypeScript does not infer types. Instead of that, it's a main power of flow. One very last thing, and we proceed to crushing TypeScript, is declare. Assume you have a module somewhere which has no typings, but in order for your code to check, you want to declare types. In that case, you just put your the special word declare, and you write the typing. So you say, okay, somewhere there is a function foo, which accepts the parameter as string and returns as a number. It's just a nice way to separate code from declarations. It's just a way to type things which are not typed by default. It is the default way how NPM modules are typed. So the typing declarations are kept separately from the code. And by declaring that here is declare, for example, declare module some module, we are saying, okay, when we will require some module, it will have an export foo with such types. This is the way to type things. Okay, let's crush TypeScript. Let's start with something primitive. I will create TypeScript file. So, here we go, TypeScript guys. Class person has name, string. Yeah. Oh, whatever. Class cat has also name, string. I have I. Of course, I'm a person. Huh, no error. Come on, TypeScript, what's wrong with you? Well, this is the major difference between how TypeScript and Flow treats classes. TypeScript always use structural typing. What does it mean? Since person and cat has same structure, they're okay for TypeScript. Everybody wants to be a cat, you know. Of course, if I change something, wait, I cheated you. In order to TypeScript work, they say you should create, let's say, create test config.json with, first of all, compiler options, target, ECMAScript 2.5. Yeah, so if we go here and well, still no error. Weird. Let's go with flow. I'm creating the same flow code with putting back name, putting back name, and of course I need to add flow header. Yeah, it's an error. They say, okay, this type is incompatible with person. Please take a note, this applies only to classes. I mean that if I declare type person this, type cat, not class, just type, yes? It will work. For common objects, Flow applies structural typing, but classes are always treated as classes. I mean that two classes of the same construction are not the same. And this is a really important thing, especially when you're refactoring a lot of code which pretty similar classes. Sometimes TypeScript becomes pain in the ass. Okay, let's go. Oh, sure. Yeah. Yes, it does not work, right? It should not work. It's JavaScript. It should not work because it's incompatible. Ah, wait. You mean, here we go. Type reference it from cat. Of course it will not work because I have no class cat. But if I can do now that const f is a cat has name meow, const I is f. That will work, of course. First of all, major difference, of course, between TypeScript and Flow is that TypeScript is a language. Flow is just adding additional typing nodes. We will talk about this a bit later when we speak about Babel. Some people hate Babel, and they are right, because it greatly makes things complex with debugging, messing with source maps, and so on and so on. So it's your right to hate Babel. I also hate it. So let's continue. We have class animal. Let's cheat a bit, just to save time from typing. Okay. Name string. We have class dog. Let's have dogs are loyal. And let's have cats. Cats like to purr. Yeah? Class dog extends animal, of course. Let's remember old good days with object-oriented classes in your university. And let's declare const animals is an array of type animal. Yeah, here we go. And it's empty. So animals push, for example, new animal. Of course, it's okay. Const cats is array of cats. Uh, of course, cats push new cat is okay. Animals push new cat is also okay. Of course, obviously, yes, a cat is an animal. Cats push animal. New animal is obviously an error. Oh, where is an error? I love TypeScript. Flow comment, no needed, it's TypeScript. I'm not one second. Oh, thank you, Visual Studio. It's updated, I think. 1 second. Yeah. Yeah, I will reload it, so. You know, Microsoft products, if something don't work, let's try to open it and close it. And yes, it works. Thank you, Microsoft. Okay, everything is pretty good right now, but okay, let's do some weird magic. I'm changing the let. It's okay, right? What I'm doing now, oh, it wants to update. Thank you. And I'm doing animals, cats are equal. I can do this assignment, right? Animals is equal to cats, right? Cats is type is more strict type than animals. It's fine, but I can also do this. Can I? No, type animal is not assignable to type cat. Property per factor is missing. Okay, but let's say do this. Animals is equal to cat to cats. Fine. Animals dot push new animal. Do you see here's a trouble here? I've recently added new animal to the cats array because arrays are copied by reference. And if I now write something cats for each cat console log cat per factor, I will be doomed, especially if this is method, if this is the invocation of some code. Thank you, TypeScript. You just saved me the day. Let's see how it works in Flow. Same code. Typing declarations are pretty much the same across TypeScript and the Flow, so I usually can just copy and paste. Adding Flow. Oops. This type is incompatible with cat. Flow understands that now in the line 20, the animals is now the cat type, not the animal one. The type inference is a great power of Flow. Okay, let's proceed more about type inference. Welcome, TypeScript. Pretty dumb function, log length, accepts. I will put 0 typings here. So let's assume it's JavaScript code. Yeah? So I can log length of some array, no error. I can log length of object which has property length, no error. I can length, oops, I'm not sure that number have a property length. Okay, let's see same this flow. Oops, property length, property not found in number. Flow without zero type annotation was able to infer types of function. So it is assuming, since it sees since I'm accessing length, that I should put it, that it should be here in each call. Okay, TypeScript, you suck. A bit more complex example, but also important. I will, in this case, just to save time for typing, use my hint, because it's a bit more typing here to show. So, It's this one. Disregard the flow, it does not mess. So we have class A, class B, class C extends A. We are assuming let A will be new B. But for some reason, sometimes, we are assigning A class C. It's a pretty common pattern. For example, when you're handling error, you're getting an error, digging it a bit deeper, and sometimes you reassign this variable with more specific error. What's the error here with TypeScript? Type C is not assignable to type B. Why? I never told you A is type B. TypeScript attempted to infer that type, and he saw, okay, you're assigning something with B type here, so it should be now forever be the B type. Let's see this flow. Still. So, no error. Why? Let's take a look what flow thinks about A. He see, okay, now A is type C, and if I put AST processing here, I will see that actually flow assumes that at this point, type of A is B or C. So, if I put AX, it will work. If I put some A.xx, it will not work because it understands. And if I put, for example, A.y, it will be still an error because it understands that at this point it may be of type C. Cool, huh? So, let's trash you a bit more. Maybe TypeScript is still better when you write types? No. Another example. Pretty function here. A bit useless, but just to demonstrate template. So we have the function promisify, which accepts some function, which accepts one parameter named I input, and returns output, and returns function which accepts the same parameters as the function we put in, and instead of output, it returns promise of output. So we just have the function which returns some primitive value, and we are promisifying this function, making sure it always returns the same the promise value. Yep. And some demo function identity, which is dumb as hell. It accepts the parameter and returns the parameter of the same type. So we have class A, which has a name, which has a method, which returns some number. And we are, okay, we're creating A. We promisify this identity function, which returns the same type, right? And let's try to call promisifyed identity A, then X. Of course, we know that X should be the same type of A, right? It's declared by identity function. Same type here, right? Oh, it looks nice. Property foobar does not exist on type object. Yes, because I do not have the foobar property on class A. But let's type xfoo. Oh, still an error. Why? Let's take a look into X. You see, it's an object. TypeScript just absolutely lost the typing parameter of A. Why? Because TypeScript do not support inferring types from polymorphic functions. Let's take a look into flow. You know what will happen, right? It works. No error, but maybe it's wrong. X foobar. An error. Let's see the type of X. Thank you, X any. Let's see. It will not. Whatever. It is capable of correctly capturing and passing through the type A. And since the promises are everywhere, it's a real pain with TypeScript for now. Real pain. I have the very last thing to show you, because I'm limited in type. I'm not touching even complex mathematical approaches like covariance, contravariance, invariance. It's just the same. TypeScript does not support almost everything of that. But the very last thing, I want to write function named object map. So we have the some object, and I will return the object which have the same keys as the object passed, but some logic applied. So basically, I will have the type here. It's an object whose keys are string, and for example, values are number. And the code will be pretty simple. Yes, let result and object keys x for each key. Result key k is equal to xk multiplied by 2. Yeah, pretty. Return result. How I will type this thing? Of course, I can tell something like copy paste this, right? But this is bullshit. Why? Because I can write this code. Const demo is equal to a2b3. Const b is obj map of demo. Console log b foo. Of course, it's wrong, right? Because currently I have zero logic about this thing. Here comes the most power of flow. It has some magic types. It usually starts with $. They are pretty different. Something like shape, for example. Shape is a magic type which contains some properties of object. But here comes the one of most powerful, obj map. We are saying that here we will accept some type T, about which we know that this is this thing. Yeah, it's the most. Oh, sorry. It looks a bit unreadable with so big font. So let me. Oh, what I've done right now. So object T is key string type number. So X will be the type of T, and the resulting value will be obj map of T, and after that I should describe the function which accepts things. So if I'm right, that will be this way. So let's see. Now it is an error because now I've just described that no, sorry. I need to describe a function which will show me the result, how the data will be transformed. Yes. And now it is an error because right now this record, the magic types is a type is a very long talk, and I'm short in time. But right now I'm describing it. Okay, the return values of this function is an object with exactly same keys as being passed of type T, which is the first argument. So if I type here B, A, it will be fine. So basically, this is the main reason why I chose Flow over TypeScript. Flow is extremely powered in inferring types. Actually, sometimes, like a good girlfriend, Flow is pain in the ass. This is because, just one more example, it will not take more than 1 minute. I love TypeScript for having enums. It's a really convenient way to do things, yes? Just to save time, I will use, here we go, the ready code, yeah? Whatever, spoilers. Really? You want to open TypeScript? Ah, yeah, same extension. So, TypeScript, what's wrong with you? Okay, I just declared enum direction with certain numerical values. Why do you allow me to call test with number 100? It's not even close to be in direction. Why? No answer, sorry. Flow does not have enums. It's pretty obvious because it is just typing addition to language. It could not introduce new constructs. So this is the enums part is the part where flow is typing is pain in the ass, not typing the ass. So in flow, you're writing this thing and it validates. You're saying that direction could be only 1, 2, 3, 4. But here we go with, but of course this is also bad since we want constants. So basically we are forced to do that. Type up type is equal 1, type down type is equal 2. I will not write them all. So here we go up type or down type. But we still can't use this up type, down type in JavaScript. They will be stripped during compilation. So we should write const up is the type of up type and equal to 1. Of course, we can skip this thing. It also works. But it is just additional type check. So if I will change up type, it will be an error here. But yes, it's a code duplication. It's pain in the ass. Another problem is, let's remember the Redux code when I was specifying action as action type 1 or action type 2. If you use tcomb, it's an excellent plugin which extends flow functionality by adding the same checks in runtime. That code will fail. Why? Because as you know, each action is being passed to each reducer. So as soon as some other type of action will be dispatched in the system, it will came there and broke everything. And you can't write, this is strongly against, you can't write this is type something like type A some data or type B some data or just type string. That will not work. Because when you're using, this is called disjoint unions, the flow should be able to separate each time which type of union he calculates. The last one captures all them all. There is no, okay, let's the rest. This is the pain in the ass and the real sadness. Another pain in the ass is that currently this thing is not supported. Type state type is the sealed object with some data. X number, F string, let's say. And let's put the flow so you see a real error. Const X of state type is an object of X1F hello. That will work. Const and function reducer hour, which accepts X of state type and returns state type. And we are doing some pretty obvious thing which is common for reducers pattern. Return, we are copying everything from X, which is parameter. And after that, we are putting some additional data, right? Calling this. And here comes an error. Unfortunately, the spread syntax, even if you use 3 dots or object assign, is incompatible with exact types. Currently, Flow can't infer that we are mentioning only the keys which are already available in state type, and this is not an error. So, unfortunately, this should be addressed in the nearest releases. But for now, for states and reducers, we have to use inexact types, which is a bit sad. Okay, some people, just coming to the conclusion, some people are against Flow because the Flow recommends Babel. You need to transpile your code to run. Okay, cool. You don't like Babel. Flow does not adding anything to JavaScript syntax. So there is a special plugin, the special transpiler, let's call it there, called Flow remove types, which does nothing, which just replacing your types in the code with spaces. No other code transpilation. What does it mean? You don't need source maps. Your position in code will be exactly the same. You don't need any complex transpiling process messing with all that stages and so on. It's just removing types. And another thing which makes Flow awesome, it's blazing fast. It's a camel-ast parsing of JavaScript tree is 3 times faster than common Esprima, which is used in many places. But if you are a hipster, like a lot of us are, you are using a lot of cool new JavaScript stuff, you will see that Flow is Facebook opinionated. That means it doesn't love decorators. It will say, okay, this is decorator, I will not type check it. It doesn't love any, for example, modern syntax, what we have here, something like x.foo, you know, yep, binding one of proposals. Big Flow will say, okay, I'm not understanding that at all. So you stick to the selection of new JavaScript features Facebook loves. But this is pretty covers most of use cases. Object spread, class property initializers, so you can initialize class properties with equal sign inside class, and so on. So we can say that Flow is forcing you to write syntax in other way. If we speak about reducers, we can make some nice thing which accepts, which makes reducer from a set of functions, each accepting certain type, and after that it will type check. Probably I will show it sometime. But for now, I think I'm out of time. I hope that your TypeScript guys are now doomed, and that people who never know about TypeScript and Flow now like Flow. Thank you. Any questions?
Thank you, Illia. Hi, we have questions, lots of.
Hello, thank you for a great presentation. Now I love Flow. And I would like to ask you about class inheritance and Flow. For example, may I declare function in one class and then only declare but not implement it, and then implement it in other class that inherited extends the first one?
Yes, this is not the common use case for JavaScript, but the Flow has magic type for that. It's called $abstract, and you can declare that this class is considered abstract class, and this will work and this will type check.
Oh, great. The question was exactly about abstract classes.
Yeah, you know, the Flow is dealing TypeScript. Okay, we have interfaces. Flow, I don't care about interfaces. If the class matches this type you've declared, I will work. We have abstract classes, Flow. Okay, we will introduce magic type.
Thank you. Thank you.
Yeah.
Thank you a lot.
Hi, Illia. And I have 2 short questions for you. Thank you for a good speech. And does it work with all IDEs or just for Visual Studio?
IDEA support was a pain just approximately half year ago, but for now, IntelliJ, WebStorm, or whatever has a full support of Flow.
Sublime.
Sorry?
Sublime.
So frankly speaking, no idea. Pretty sure it has. Well, let me a second. Give me a second. Atom Code has a Nuclide plugin developed by Facebook for Flow. Visual Studio Code has 3 plugins. Each of them has its benefits. One of them was developed also by me. And about Sublime, I have no idea. But even if it does not have, there is a special project called JSLint plugin Flow, which converts Flow errors to JSLint errors in case you have no Flow support for your IDEA. And it works everywhere where you have JSLint support.
Okay. And what's the main pitfalls of Flow except spread operator?
Let me show. Sometimes you need to have a good understanding of math. Let me show one small piece of the real project. Yeah, just it will take 1 second. Sometimes you are blowing your head with, what the fuck? Why I need to write this? And why does it work? It was not about TypeScript. So let's show me the thing. Yeah, here we go. It's a good thing, yeah, some very, very dark magic messing around, like type inferences, yeah, you can scare children with these typings. But the problem is here. Really, what you can see at these lines is a pretty mess from the JavaScript point of view. You are creating the function and immediately invoking it. Why? Why I can't just put bind there? There is a link which leads to 20 pages length article. Understanding why we need that, because inferring polymorphic types with template bindings is unresolvable. Frankly speaking, I understand what I'm said just approximately 20%. But sometimes you will need to look into that hacks, but this is because Flow has strong mathematical basis. And it will never allow you to broke type inferring. It's a key feature of Flow. So sometimes you will write this weird code. And sometimes, like I said, Flow is forcing you to write, for example, reducers. We are writing them in this way, just to show you. So, for example, oh no, that's a bad example. Don't remember. Oh, that will work. This is another approach to reducer which plays with Flow nicely. We have a helper function make reducer which accepts function for handling each type, and after that we are making reducer in this way. You see? Type and function which returns new state. This thing makes Flow very happy. It's easily to type check. Do not have the problems with this inexact types. But yes, sometimes Flow is forcing you to write the code in other way, not the way you are common to. And this is not bad. This is just some trade-offs you have to pay for having strong type checking.
Sorry, I have a question. Can you go back to your presentation about animal, dog, and cat?
Sorry about what?
Animal, dog, and cat. You say that you would avoid such a thing as variance, but I think this example is exactly about it, and I'd like to know how Flow handles it. Can you put, please, a function that accepts array of animals and put and pass array of cats into that function?
1 second. I check if I saved it. And 1 second. Let's see if I have its implementation. So we will save type. If no, no, sorry.
So,
I will ask
my question is: I understand that TypeScript did what it did by deliberate reason.
Yes.
So they didn't want to introduce variance.
Yes. And just to answer your question, I understand why TypeScript did it, but sometimes it's an easy way, like I told you, to shoot yourself into your leg.
Yeah, but
sorry.
What is the approach of Flow?
Flow approach is, okay, you need covariance if you're already speaking with, okay, you will get it. So if you open docs, I know showing the docs is a bit, said you can declare, there should be classes, class declarations. It was quick reference. No, I need big one. So you have a special thing for treating several properties or function of covariance. So by adding the plus sign, you can relax, and minus sign, you can relax or restrict this as you wish. I think you know by positive and negative positions, yes, invariance.
Yeah, I'm interested how it works if it's a generic position, if it's part of an array. Just like in your example, array of animals, and I want to pass cats there.
Let's give a try. May I will, meanwhile,
my point is that you are pointing, you are not fair to TypeScript here. You are pointing to benefits, but avoiding a little drawbacks.
Okay.
Of your favorite flow.
Let's have a try while I'm typing. Maybe I'm answer some other question, and we will get back to you. Any other questions? Yeah, sorry, go on.
One, check. Thank you for this speech. The question is how Flow works with third-party libraries if you are importing library which written without any flow, typing, etc. In TypeScript we use typing and we can use all this benefit, but what with Flow?
It's pretty easy. Flow supports, there is a project called Flow Typed, which aims typing libraries. And as I showed, you can add typings even the library do not have one. You just put it to the Flow Typed folder, it's especially called. And there is a special utility which is you just call Flow Type install, and after that it will look for npm and will dig all typings which are available for you, and after that you can extend it, overwrite it, you should commit it to your Git repository. Yeah, any more questions before we get to the...
All right, we don't have actually time, we have just 5-minute break, so thank you to Illia, thank you for the questions.
Yeah, thank you.